Well, good morning, everyone. My name is Thompson, and I'm the lead naturalist with Aurora Open Space, and welcome to another video in our Discovering Aurora's True Natures education video series. So, just a couple of reminders with this video, with these videos. We've sent you some pre-questions to take a look at while you're doing some of the activities in these videos and watching these. So when you're watching the video, if you want to stop at certain points and ask yourself those questions and see if you can come up with the answers. I'm also going to be asking you questions throughout the video, and you can kind of stop the video then and see if you have answers to those as well. Okay? So this program is called Ancient Aurora, and the idea behind this program is that we can tell what's happened here on our planet before we were here because of the stories that we find in the rocks. Okay? So to start off with, sitting at home, what I'd like everybody to do right now is take a look outside the window. And I want you to say a few things to whoever is around, to your adult, to whoever is there, about what you see in your area. So do you see trees? Do you see people? Hopefully you don't see too many of them right now. Do you see cars? Do you see buildings? What do you see? So go ahead and stop the video now, take a look at what you see, and tell somebody what you see outside your window. Okay, great job. So my guess is that you did see buildings, and you did see some cars, and you did see some trees. So do you think that those buildings and those cars and those trees were here last year? Okay. Do you think that they were here 10 years ago? What about 50 years ago? What about 100 years ago? 100 years ago, do you think you would see the cars that you see outside? Do you think you'd see the buildings? What about 1,000 years ago? Or 1,000,000? Now, my guess is that none of you were alive 1,000,000 years ago. I mean, even I wasn't alive 1,000,000 years ago, and I'm a lot older than most of you. So we were not around to see what some of these things may have looked like, or what our planet may have looked like 1,000,000, 2,000,000, 10,000,000, 70,000,000 years ago. So how do we know what happened? How do we know about what did happen during these times? And my answer to that, and according to the story told by scientists, is that the answers to answer these questions are answers that we can find when we read the stories in the rocks. And before I continue, I do want to say that this is just one belief, one story about how our planet was formed, and this is the story that's told by science. Okay? And that's what we'll be focusing on today. So what do I mean by the stories in the rocks? Do rocks talk? Obviously, rocks do not talk, although I know some geologists that would disagree with me on that. But for the most part, we can agree that rocks do not talk. So what kind of story am I talking about? Well, I'm talking about the rock cycle. So how many of you are familiar with the water cycle? We may have heard that water goes through its own cycle. Well, the rock cycle does the same thing. Rocks can't be created or destroyed, they just change forms. And this next activity is going to show us how that happens, okay? Now, this is an activity where you've got to get up out of your chair, so if you're at home, I'm expecting that you're standing up, okay? So we're going to start. Everybody get up, get out of your chair, you're going to be moving around, going to be having a little bit of fun here. We're actually going to start down on our hands and knees, because this is kind of where the whole story starts, is underground. This is where the rock cycle, this is where this part of the rock cycle starts. So we're actually going to start by being magma, okay? And magma is liquid that moves underneath the surface of the earth. And when it's pretty cool underneath the surface of the earth, that magma moves pretty slowly. So at home, I'm expecting that you're moving kind of slowly along the ground. Now, at some point, you may just heat up. Okay? And in order for heat to happen, you need to develop some heat. You need to move faster, so you need to develop some heat. So everybody rub your hands together, and you're probably going to feel that your hands are a little bit softer. So now you've got some heat. And now, as you probably know with liquid, when it warms up, it moves quicker. So now you can move a little bit quicker along the ground. So move a little bit quicker, and you're moving quicker, and you're moving, and you're quicker, and you're moving quicker. And pretty soon you come to a crack in the surface of the earth, and you're going to explode through that crack. So everybody ready? 1, 2, 3, explode out of the crack in the earth. Great job. So now that you come out of the crack in the earth, you are no longer magma, you are lava. And you've probably seen pictures of volcanoes with lava coming out. That is what you are right now. So when you come out, you've got a couple ways you can do it. You can come out really fast and then freeze because you cooled really quickly, Or you can come out really fast and then move around really quickly, move around quickly, and then slow down, slow down, slow down, and stop. And when you do that, that shows that your lava that has cooled down rather slowly. And why is this important? Because this is the kind of rock that is called igneous rock. And igneous rock often has crystals in it. And the crystals can be formed based on the temperature that they came out at. So if you came out and you cool down really quickly, then usually those crystals are really small. But if you cool down, you moved and then you cool down really slowly, then the crystals had more time to form, and you can be bigger, you can have bigger crystals in you as an igneous rock because you formed more slowly, okay? So, great job. Now we're gonna take a look at some real actual igneous rocks. We have a few that are right over in here, and you can read the titles that are on there. I can't see them from where I am right now, but you can take a look, and some of these actually do have some small crystals in it that you can see formed as that lava, as that magma exploded out of the ground, became lava and cooled down, okay? So the next kind of rock that we have is called sedimentary rock. And sedimentary rock is actually what happens when igneous rock has been present for a long period of time. So as igneous rock, remember, you came out and you froze and you've got your crystals in you. Well, you're above the surface of the earth now, and above the surface of the earth, the forces of nature can act on you. So maybe some wind blows you around, so you're standing up, you're blowing around, make sure everybody's blowing around in the wind, or rain is falling on you, or an animal might be peeing on you, or a plant might be growing on you. So the forces of nature are acting on you, and little by little, they break you down. And this happens over a long period of time. This happens over many, many years. And so pretty soon, as a sedimentary rock, you are laying down on the ground. And so everybody get down on the ground. As a sedimentary rock, you are laying here. And a lot of times you'll see sedimentary rock as layers in the earth, and you can see those in different places throughout the Denver area. So you're laying on the ground as an igneous rock, and along comes everybody's favorite dinosaur, T-Rex. Here he comes, and he's lumbering along, and he's lumbering along, and he's lumbering along. And all of a sudden something happens, and he dies, and he lands on you, okay? Now, sedimentary rocks are some of the best rocks in which to find fossils, because with fossils you need three things. First of all, you need hard parts, so you need some bones. You need a catastrophic event, so like an earthquake or a volcano or something that buries that animal rather fast. And you need time and lots of it, okay? So T-Rex is walking along, earthquake comes, he falls and he lands on me, on the sedimentary rock, and he dies. And over time, layers of rock fall on top of me. We're all sedimentary rock, and layers of rock fall on top. And then eventually, at some point later on, somebody could come in and dig through those layers of rock and find those bones. And they may not find the bones all together, they may find just pieces, but they'll find some of these bones. And that's one of the ways that we know that sedimentary rock can be one of the best places to find fossils, okay? So, I'm gonna go ahead and set T-Rex over here. So we're still sedimentary rock, we're still laying on the ground. Now over time, we have many layers of rock form on top of us, okay? And I'm actually gonna bring T-Rex back because he can make another appearance here. So we're on the ground and we're underneath many, many layers of rock, and we're closer to where there's heat now. So again, we're gonna make a little bit more heat. Now we have some heat, and as things are heating up, things underneath the surface of the earth are heating up, you are going to bend. So when I say 3, you're going to bend in whatever way you want to. Everybody ready? 1, 2, 3, bend! So you could bend up, you could bend sideways, you could bend pretty much any way that you want to. What happens with the earth when it bends is that it lifts up. And a lot of times when the earth lifts up, that's where you get mountain ranges forming, and that's where you have earthquakes and different layers of rock are exposed. And so that's where T-Rex, his bones, could actually be exposed then too. There are layers of sedimentary rock under the ground. That rock changes when it bends, and it's called metamorphic rock, okay? So we have 3 different kinds of rock. We have igneous, we have sedimentary, and we have metamorphic. And we have a couple more examples over here of the sedimentary and the metamorphic rock. Sedimentary, like I said, often you can see in layers. And then metamorphic rock, also you can see in that rock, you'll sometimes see crystals, you'll sometimes see bigger shapes and formations, because that's a result of that rock having been exposed to heat underground and changing. Metamorphosis is change, so metamorphic rock is changing. So those are the three kinds of rock, and when those three kinds of rock are exposed, we can find different things in them, and they help tell the story of the Earth. So we're going to stop this video right now and give you a chance to answer some of the post questions that are a part of this. When we come back, the next video that we talk about is going to be taking how we use the rock cycle and telling some of the stories that the rocks have told us throughout time. So I'll see you guys in a little bit.